The title for today's program is Paradigm Shifts Across the Ages. I'm hoping one of our 5 esteemed speakers will be able to explain to us what a paradigm is. As Kuhn famously had, I think, 22 different definitions in the structure of scientific revolutions. But without hesitation, let me first of all welcome Professor Liba Taub from the University of Cambridge, who's going to talk to us about paradigms in the eye of the beholder. Aristotle, Ptolemy and Copernicus. Professor Taub. Thanks.
Well, it's nice to see so many people braving what looked like it was going to be horrible weather this morning. And I'd just like to thank Joe Ashburn for inviting me to join you today at this History of Physics conference on paradigm shifts across the ages. I confess that I'm not going to explain any of the 22 definitions of paradigms that Kuhn gave us. I was very pleased to receive the invitation to speak on the demise of Aristotelianism and the ascent of Ptolemy and Copernicus. I was delighted because many years ago I militated in a somewhat academic fashion against referring to anything that we might call an Aristotelian Ptolemaic system. And I did this for a number of reasons. And indeed, I've long accepted the arguments of the historians of astronomy, Otto Neugebauer and Noel Swerdlow, that Copernicus had more in common with Ptolemy than we have sometimes been led to believe. Nevertheless, the conference description for today explains that the history of physics can be viewed as consisting of major paradigm shifts followed by decades and even centuries working through the consequences of the dominating paradigm. As examples, the Copernican revolution overtook the millennium-old Ptolemaic system of astronomy, and likewise Newton's mechanics replaced the ancient Aristotelian system. So what's going on here? Why was I asked to talk about the decline of Aristotelianism and the rise of Ptolemy and Copernicus when at the same time we're talking about a Copernican revolution overtaking the Ptolemaic astronomical system? Well, my short answer is that paradigms are in the eye of the beholder. And I note with pleasure that the next speaker, Rob Iliff, will talk about Newtonianism, one paradigm shift or many. And while I haven't yet heard what you're going to say, Rob, I'm hoping that you, as I am, will be trying to complicate the ways in which we think about paradigm shifts, noting that there may be any number of different things we identify retrospectively as paradigms operating at any place and any point in time, to say nothing of the spans of different historical periods, such as antiquity and the Middle Ages. So what different paradigms might we identify? Okay, I couldn't resist having this wonderful image of, I think, that purports to be Aristotle, Ptolemy, and Copernicus. And that's on the frontispiece of Galileo's Dialogue of the Two Chief World Systems. So I want to identify at least 3 different possible candidates for being paradigms. A so-called Aristotelian Ptolemaic paradigm, which seems to be mainly predicated on a geocentric cosmology or geostatic cosmology, and an astronomy based on circular motions. But it's important to recognize that Aristotle was primarily interested in cosmology, that's physics, rather than astronomy, which is mathematics. And Ptolemy was primarily interested, or so it seems, in astronomy, mathematics, rather than cosmology, physics. Then we might point to a Ptolemaic Copernican paradigm in which mathematics is emphasized and in which circular motion is required to explain astronomical motions and in which physical explanations are not emphasized or even much discussed. But then we might also find another paradigm in which the cosmos has a source of light and heat that could be a fire or even the sun, our sun, in the middle of the cosmos, and an epistemology in which mathematics is also emphasized. This might be called a Pythagorean paradigm, seen, for instance, in what some early modern authors refer to as a Pythagorean Copernican approach. In my talk today, there are a few key points I wish to make. First of all, I want to highlight the trickiness of understanding what is meant by Aristotelian. This word means different things to different people. In other words, what we call Aristotelian, an Aristotelian worldview, may not be the whole picture of what we find in the Aristotelian corpus, the writings that are attributed to Aristotle. But they may be due to a later understanding or a later interpretation of what he thought. Furthermore, I want to raise a question as to what we understand by the Aristotelian worldview or Aristotelian cosmos, how much that seems to match up with the writings we have that are pretty safely attributed to Aristotle. So does the Aristotelian worldview cohere at all with what we think he thought? Then I'd like to ask whether or not there was an Aristotelian Ptolemaic worldview. In other words, was there some sort of joint Aristotelian Ptolemaic understanding of the cosmos? Or did Ptolemy, in some ways, reject at least some of the ideas of Aristotle? And did Ptolemy then rise to an ascendancy? And we might explain this as maths being emphasized over physics. Then I'd like to point and highlight to the idea that Copernicus and Ptolemy had much more in common than we are sometimes led to believe. And finally, we can also make the argument, claimed by Copernicus himself, that he wasn't really doing anything new at all. He was only following the ancient Pythagoreans in placing the sun in the middle of the universe. And I note, like the Pythagoreans, he was also emphasizing mathematics. Now, it's also important to recognize that Aristotle, Ptolemy, and Copernicus may actually have been trying to answer different sorts of questions. And they were certainly presenting their ideas to different audiences. And here, the ancient and medieval distinction between cosmology as physics and astronomy as part of mathematics is useful, once again, to keep in mind. However, even having said that, it's worth noting that Aristotle, a philosopher, showed knowledge and interest in mathematics, even though at some points he suggests that we should leave certain problems to the mathematicians, who he identifies as a specialist group. And Ptolemy does very self-consciously, in the Syntaxis and the Almagest, identify himself as a philosopher, even though we normally think of him as a mathematician par excellence. So first of all, let's consider Aristotelianism. And here, as I've already suggested, I'd like to distinguish between those ideas which we can reasonably ascribe to the man himself, based on his writings that we pretty securely think he was responsible for, and other ideas that might have been due to his followers, either in antiquity, the so-called members of the so-called peripatetic school. And it's important to recognize that also in the medieval and early modern periods, there are some ideas that are labeled Aristotelianism that probably weren't even really thought up until the Middle Ages. And it's not clear that if he walked in the room while these were being discussed, that he would recognize that they had anything to do with him. So Aristotelianism is sometimes a slippery term. Now, because the history of early modern science is so often depicted as a rejection of Aristotelian Copernicus, because the early modern period is so often depicted as a rejection of Aristotelianism by Copernicus and others, it seems important for our purposes to flag up this issue. And the following is a fairly typical, but I think very nice and succinct description of that Aristotelian worldview or cosmos. It's from David Lindbergh's Beginning of Western Science. David was a very distinguished historian of medieval science and an expert on optics. Aristotle divided the cosmic sphere into two distinct regions, made of different stuff and operating according to different principles. Below the moon is the terrestrial region, formed out of 4 elements. Above the moon are the celestial spheres, to which the fixed stars are attached. This celestial region, composed of ether, or the quintessence, is characterized by unchanging perfection and uniform circular motion. As I said, it's a very succinct definition. And it's one that I think most people assume to be typically Aristotelian, a very sharp divide between these two regions of the cosmos, the celestial and the terrestrial. And Aristotle's account of matter and its motion is the heart of his differentiation between the two regions of the cosmos, both with their own type of matter and motion. And furthermore, Aristotle did not refer, except in passing, to any interaction between these two regions. I'm not going to speak to all of my slides. I've put some of them up so that you have something interesting to look at. I want to just remind you, though, that some of them were designed and made long, 2,000 years after Aristotle wrote what he had to say. So how Peter Appian has depicted what he regarded as the Aristotelian cosmos, we don't have any images that Aristotle used to accompany his works, even though actually he does in some of his works refer to some things that probably were some sort of illustration. We don't have them. And I'll just mention that now because you'll be seeing some other things that are labeled Ptolemaic, for instance. They're not based on anything that Ptolemy presented as a drawing. Now, in On the Heavens, De Caelo, Aristotle explained that the heat and light of the stars, including the sun, is the result of their motion causing friction, which causes the air below to be ignited. This is the reason that we feel hot when the sun is near or overhead, because the air is especially heated. And here Aristotle attributes a change in the terrestrial realm to the motion of the celestial bodies. We might not expect this, according to what's sometimes given as the standard view. Then there are also several passages in the meteorology that are relevant. So in addition to the warming activity of the sun, the heavenly motions also determine the terrestrial winds. For the air surrounding the earth follows the motion of the celestial bodies. Marshall Clagett long ago pointed out that initially Aristotle had given sanction to the influence of the movements of the celestial bodies on the terrestrial or sublunar world. And he cited a passage from the meteorology. The sublunar world is tied in some way and in a necessary manner to the local movements of the superior world in such a way that all the power which resides in our world is governed by these movements. So Clagett's point and my point is that sometimes when we go straight to the man, to Aristotle, we find something that's not quite what we expect from later terms and descriptions of what's Aristotelianism. So this two-region sharp division is probably not as sharp as we're sometimes led to believe. Now let's turn to the question of whether there was an Aristotelian Ptolemaic worldview. In other words, some sort of dual Aristotelian Ptolemaic understanding of the cosmos. Now it's important to recognize that in the Greco-Roman period, and for hundreds of years following, astronomy and natural philosophy were typically understood to be completely distinct realms of inquiry. I've already alluded to this by saying that we think of Aristotle primarily as a philosopher and Ptolemy primarily as a mathematician. Now, according to the Pythagoreans, there were four types of mathematics: arithmetic, harmonics, geometry, and astronomy. And some ancient discussions describe astronomy as offering an account of apparent motions of astronomical bodies using geometrical models. This is in contrast to natural philosophical discussions of the celestial bodies, which were concerned with explaining the cosmos as a whole, for instance, the order of the celestial bodies and what they're made of. Aristotle was, according to this division of labor, a physicist, while Ptolemy was a mathematician pursuing astronomy. And in the first book of the Almagest, Ptolemy presented the physical or cosmological assumptions, the hypotheses that served as the foundation for his astronomy. He said this was necessary to know what these were before delving into his mathematical astronomy. He explains that he's presenting these ideas, which I'll come to in a moment, only for the sake of reminder, suggesting that we're already supposed to be familiar with them. they're not going to be a surprise. And that for that reason, he says, only a summary outline will suffice, since they will be completely confirmed and further proven by the agreement with the phenomena of the theories we shall demonstrate in the following sections. So in other words, he thought that most readers would find his physics, his physical assumptions, perfectly acceptable. And he says that the first order of business is to grasp the relationship of the earth taken as a whole to the heavens taken as a whole. And he goes through and presents his physical hypotheses. The earth is spherical in shape and moves spherically. The earth is also, when taken as a whole, sensibly spherical in shape. The earth is in the middle of the heavens with regard to the senses. All three of these are also points that were held by Aristotle as well. However, in Ptolemy's discussion of them, perhaps surprisingly, he doesn't actually refer to Aristotle's own discussions or justifications of these hypotheses. Now, this may be for any number of reasons, but I think that it's significant that not all of Ptolemy's reasons that he gives us for adopting these physical hypotheses agree with those of Aristotle. And then when we turn to the fourth hypothesis, that the earth has the ratio of a point relative to the size of the heavens, we find a marked divergence from Aristotle, who never discussed this idea, but only hinted at it. Aristotle had stated that the size of the earth is small as part of his larger argument about the sphericity of the earth. When Ptolemy claimed that the earth has the ratio of a point relative to the distance from the fixed stars, he was following a tradition set up by mathematicians. In the first proposition of the phenomena, Euclid stated that the earth is in the middle of the universe and occupies the place of center in relation to the universe. And this was an idea that gained some following amongst later mathematicians. Aristarchus, in the 3rd century before our era, stated that the earth is in the relation of a point and center to the sphere of the moon. Geminus, whose dates are not really well known to us, possibly 1st century before our era, possibly 1st century after, he said that the whole earth has a ratio of a center to the sphere of the fixed stars. Now, I'm very deliberately trying to enunciate point and center here. Very important to distinguish from middle. They're mathematical terms. And it's in his discussion of the hypothesis 5, that the earth has no motion from place to place, that Ptolemy is most Aristotelian. But even when he's being very Aristotelian, he's still not strict. And while he relied to some extent on the pattern of Aristotle's argument against the idea of the earth's motion, he doesn't follow Aristotle's argumentation. In fact, he refers to the ideas of people who lived after Aristotle, showing that he knows that things didn't stop with Aristotle, but have moved on. So given that there are some differences as well as similarities between their thinking, are we entitled to refer to an Aristotelian Ptolemaic paradigm? As I've already hinted, one big difference between Aristotle's approach and that of Ptolemy was that the latter emphasized the primacy of mathematics. Ptolemy emphasizes the importance and benefits of engaging in mathematical explanation. And we also see that this is what he thinks his own contribution is going to be, and he identifies it as a type of scientific progress. He says that this is his goal in the syntaxis, it's the Greek name for the Almagest, to pursue those studies which have already been mastered by those who approached them in a genuine spirit of inquiry, and by ourselves, this is Ptolemy speaking, attempting to contribute as much advancement as has been made possible by the additional time between those people and ourselves. Once again, he's recognized that things have moved on since Aristotle. And of course, hundreds of years have passed. At various points, Ptolemy refers to the ancients. And clearly he puts Aristotle in that category as being one of the ancients who lived long ago. But he had a genuine spirit of inquiry. But according to Ptolemy, his ideas could have been improved on by more work. Ptolemy did not evidently see himself as being bound by Aristotelian ideas, and I would suggest neither should we. So was there an Aristotelian Ptolemaic paradigm? Not for Ptolemy, I don't think. Now let's turn to Ptolemy and Copernicus and see what they had in common, including any shared paradigm. Copernicus is often portrayed as a revolutionary figure who advocated a heliostatic, if not a heliocentric system. Yet his monumental work, De Revolutionibus, is very far from a revolutionary manifesto for modern astronomy. Furthermore, while Copernicus is often described as a revolutionary figure, he can also be understood as being the last representative of the Ptolemaic tradition. De Revolutionibus very closely follows the structure of Ptolemy's Almagest. Similarly to Ptolemy, Copernicus considered cosmological questions in the first book of De Revolutionibus, and it follows closely the structure of the syntaxis, the Almagest, being based on parameters and also data explicitly taken from Ptolemy, and he refers to Ptolemy. Copernicus provides a model of the universe in which the Earth and all the planets circle around the sun, and the Earth has a daily rotation. Copernicus established the order of the planets and devised a system accounting for their movements. He was motivated by a desire to rely only on uniform circular motion, which was itself a classical idea. In his preface, he explained that the principles and assumptions, which he says were called hypotheses by the Greeks, that's what Ptolemy called them too, had been a source of some disagreement. He stated that I acknowledge that I shall treat many topics differently from my predecessors, and yet I shall do so thanks to them, for it was they who first opened the road to the investigation of these very questions. Sounds like he's standing on the shoulders of giants. Copernicus then went on to discuss the following cosmological topics, and like Ptolemy, he only presented a brief outline of them. The universe is spherical, the Earth is also spherical, the Earth forms a single sphere with water, the motion of the heavenly bodies is uniform, eternal, and circular or compounded of circular motions. Does the Earth have a circular motion? What is its position? The immensity of the heavens compared to the size of the Earth. Why the ancients thought the Earth was at rest in the middle of the universe as its center. The inadequacy of the previous arguments and a refutation. And then a question, can several motions be attributed to the Earth and the center of the universe? Here, Copernicus stated that since nothing prevents the Earth from moving, I suggest that we should now consider also whether several motions suit it, so that it can be regarded as one of the planets, for it is not the center of all revolutions. And he went on to elaborate his cosmological views. I'm quoting, "At rest in the middle of everything is the sun. For in this most beautiful temple, who would place this lamp in another or better position than that from which it can light up the whole thing at the same time? In this arrangement, therefore, we discover a marvelous symmetry of the universe and an established harmonious linkage between the motion of the spheres and their size, such as can be found no other way." His system used only uniform circular motions, correcting what he regarded as a serious flaw in Ptolemy's approach. Once again, I'm quoting from him. "I was impelled to consider a different system of deducing the motions of the universe's spheres for no other reason than the realization that astronomers do not agree amongst themselves. In their investigations of the subject, some introduced a good many ideas which apparently contradict the first principles of uniform motion. Nor could they elicit or deduce from the eccentrics the principal consideration, that is, the structure of the universe and its true symmetry of its parts. On the contrary, their experience was just like someone taking from various places hands, feet, a head, and other pieces, very well depicted it may be, but not for the representation of a single person, since these fragments would not belong to one another at all. A monster, rather than a man, would be put together from them. Now, some historians have argued convincingly that the choice between the Ptolemaic and the Copernican approaches rested on aesthetic criteria. I tried to emphasize in reading out from Copernicus's use of the words harmonious and symmetry. The Copernican model replaced Ptolemy's eccentric circles and equants with more epicycles. And in fact, Copernicus had even more epicycles in his system than Ptolemy had in his. Michael Crow, and I brought a copy of his book, which I commend to you for several reasons, not least of all, he gives some important texts by Ptolemy and Copernicus. He states that in one sense, the new theory that Copernicus presented differed significantly on only a single mathematical detail from the Ptolemaic system. Copernicus, as it were, proposed that a new point be taken as the center of the coordinate system used by the astronomers. So is this a paradigm shift? Well, here it's worth noting that a number of followers of Copernicus saw him not as presenting anything new, but as primarily revising the ancient Pythagorean worldview. Indeed, Copernicus himself, in his preface addressed to Pope Paul III, suggests that the Holy Father may have been wondering, quote, how it occurred to me to venture to consider any motion of the earth against the traditional opinion of astronomers and almost against common sense. He notes, quote, for a long time I reflected on this confusion in the astronomical traditions concerning the derivation of the motions of the universe's spheres. I undertook the task of rereading the works of all the philosophers which I could obtain to learn whether anyone had ever proposed any motions of the universe's spheres other than those expounded by the teachers of astronomy in the schools. And in fact, I found in Cicero that Hecataeus supposed the earth to move. Later, I discovered in Plutarch that certain others were of this opinion. I have decided to set his words down here so that they may be available to everyone. So, following Copernicus, I have them here so that they can be shared with all of you. Some think that the earth remains at rest, but Philolaus, the Pythagorean, believes that, like the sun and moon, it revolves around the fire in an oblique circle. Heraclitus of Pontus and Epiphanes the Pythagorean make the earth move, not in a progressive motion, but like a wheel in a rotation from west to east about its own center. Therefore, having obtained the opportunity from these senses, Copernicus says, I too began to consider the mobility of the earth. Now, according to Edward Sherburne, who provided a biographical list of astronomers since Adam, and Adam is the first astronomer, we're told. He gives this to us in his Sphere of Manilius, published in 1675, a work that was primarily a very extended argument for the necessity of obtaining better financial backing to provide better astronomical instruments to further the progress of English astronomy. Sherburne gives us a catalog of the most eminent astronomers, ancient and modern. And I apologize for this blurriness. One of the reasons I wanted to show it to you at all was just to show you that it is a very extensive and lengthy list of astronomers, once again starting with Adam. It's also available online in early English books online if you want to take a look at it. And Copernicus is blurry there, but he's here. I'm going to read out some of what Sherburne had to say. Copernicus, the year before his death, at the instance of the cardinals, he published his noble work, De Revolutionibus, in 6 books, in which he not only revived, but most happily united and formed into hypothesis of his own the several opinions of Philolaus, Heraclitus Ponticus, and Epiphanes the Pythagoreus. For according to the opinion of Philolaus, he made the earth to move about the sun as the center, whence its annual motion. And with Heraclitus and Epiphanes, he likewise gave it a motion like that of a wheel about its own axis, whence the diurnal motion. Sherburne here is reflecting the common view of the late 17th century in referring to the heliocentric system as the system of Philolaus and Copernicus. Although in the Philolaean conception, it's actually a cosmic fire that's at the center of the universe, not the sun itself. And indeed, the Carmelite theologian Paolo Foscarini defended Copernicanism as compatible with Scripture in an open letter originally printed in Naples in 1635, in a letter on the Pythagorean and Copernican opinion on the motion of the earth and stability of the sun. It's also a nice photograph of that book. I'm just also going to show a few images of Ptolemaic and Copernican models from later periods. Now, some historians have argued that we don't see a real paradigm shift until Johannes Kepler in the 17th century with his elliptical orbits, in which he allegedly referred to as simply a cart full of dung, recognizing in a sense something that had considered to be fundamental, that is the beauty, simplicity, and symmetry of the circle and of uniform circular motion, that he had been the one to abandon this. He referred to it as a cart full of dung, recognizing that this was something fundamentally different. So was that our new paradigm? Well, I'm not so sure of that either, because we can also understand Kepler himself as being the last great Pythagorean, because in a letter to Galileo, dated the 13th of October, 1597, he wrote to Galileo, quote, "You are following the lead of Plato and Pythagoras, our true masters." So I'd like to end by noting that while Thomas Kuhn referred to an Aristotelian Ptolemaic tradition, this conception is really a medieval and early modern product. In spite of their different approaches, the convergence of the general cosmological conclusions of Aristotle's De Caelo and Ptolemy's Almagest led to a unified geocentric cosmology based on arguments derived from both sources. And we see this in some of the school texts. And remember, Copernicus complained about the astronomy that was being taught in schools. Well, what was that astronomy being taught in schools? Some of it we can credit to or blame on Sacrobosco, on his Sphera. He died in 1256. And from the 13th to the 17th centuries, university students learned their basic spherical astronomy from Sacrobosco's De Sphera, and they would have received an impression of the profound unity between the two principal sources of ancient cosmology, namely Aristotle and Ptolemy. But Sacrobosco had traced his general cosmological views back to the authority of these two sources, and in doing so, he sometimes skipped over bits, shortened them, or oversimplified the arguments that were being presented, and he tended to present their opinions as if they were shared, as part of the same conception. So I would suggest, and I'm following here Pietro Amadeo and Irina Tupolova, that if there was an Aristotelian Ptolemaic tradition, it was a product and possibly a paradigm of the Middle Ages. But more importantly today, I hope that I have shown, even in a brief outline, that paradigms often depend on the reading of the interpreter and also the eye of the beholder. Thank you.
Professor Taub, we have about 10 minutes for questions. I'm sure there are a few. One here.
Yeah, so I'd like to ask about the role of observation. So to what extent did Aristotle and Ptolemy rely on making observations as accurately as they could, versus saying things like circles are perfect, so they must be circles, regardless of observation?
Well, I think for Aristotle, he's interested in circles, but he doesn't think that he's responsible for those. He sees those circles as being the specialist work of the mathematicians. On the other hand, he does rely on observation alone. And so he's not really doing what we would call astronomy, but in his physics, he's relying on observation. He also will sometimes use analogies to everyday experience to talk about what might be going on higher up in the universe. In terms of Ptolemy, he is a mathematician, and he's committed to a certain geometrical explanation of the motions of the heavenly bodies, but he's also very much committed to observational astronomy as well. And we don't have many records of his observations, but we do have him clearly making some, but also interestingly relying on older observations, and in some cases crediting the sources of those observations, for instance, his predecessor, Hipparchus. He also complains at length about some of the astronomical instruments that were apparently available in Alexandria, and that they've been outdoors, they're not in great shape. He also, in the Almagestra Syntaxis, gives some very detailed explanations of how to make some instruments, so for instance a globe, but also how to use them. So, historians have argued as to what his actual commitment was to observation. It seems to have been at least as great as that of Copernicus, who also very deliberately uses some of his data.
Okay, thank you very much. The question over here.
Thank you very much. If we concede, albeit it's a medieval, early modern creation, and we say there is something like a Ptolemaic Aristotelian paradigm, or tradition, as you latterly referred to, is there then a difference in calling it a paradigm? If you call it a paradigm as opposed to a tradition, is there any added value analytically, historically?
Well, before I come to that, let me also, I didn't point to it when I was speaking. I was trying to be very careful when I talked about approach or tradition or system. And I really wanted to not talk about the Ptolemaic system because I don't think there was one in Copernicus' sense. There's not, he's treating the motions of the bodies separately, and that's important to remember and keep in mind. But in terms of tradition, I think it depends a little bit on what historians might call historiography and what sort of story we're trying to tell. And of course, Kuhn was interested in discontinuities and when things change and how radically do they change. I think that changes certainly do occur, but there's also quite a bit of similarity sometimes. And I think part of my point is that depending on the story we want to tell, we can cut up this cake or this pie differently and give different accounts. So one of the things that I didn't allude to at all, I thought there wasn't time, was in recent years, in the last 10 or 20 years, there's been a fair amount of work done on whether or not there were precursors to Copernicus in the Islamic world, amongst the Islamic astronomers. And yes, indeed, there was. But what that story might look like, I don't think we know much about transmission. And as historians, that's one of the things that we'd like to know is how do we get from point A to point B? I mean, is there such a thing as simultaneous and independent discovery, et cetera? So I think with paradigm, and my colleagues are going to be talking more about this later, I think it does depend on what you're trying to explain.
Okay, thank you very much. We have a question from the middle.
Yes, going back to Copernicus, who you pointed out recognised that he was standing on the shoulders of giants. But it's a huge leap from an Earth-centred concept of the universe to a heliocentric concept of the universe. And his quote, "Who would do anything other than putting such a beautiful source at the centre," has almost got a religious feel to it. Would you comment on that, rather than that a religious feel rather than based on observations or a new theory?
Yes, I would like to comment on it, and it's one of the reasons why I brought this, because I would encourage you. Crow has quoted quite a bit of Copernicus there, and it's one of the reasons I wanted to read out that passage. I think it's very striking. It doesn't just sound scientific, it seems almost spiritual or maybe even mystical. And I think that that's deliberate. I think that there is there's a veneration of the artisan, as he calls it, of the universe, of Almighty God, and he speaks about Almighty God. He is a religious man himself. Right. So that is clearly part of what is being motivated here. We see that in Kepler as well. I mean, we see this in other astronomers. I think if we go back further to Plato and the Timaeus, we will see something similar there. It's interesting that he doesn't refer to Plato and the Timaeus. I mean, who he refers to, I think that's a topic for another day, and I'm not sure that the work's actually been done. He knows as Ptolemy knows, and Ptolemy refers to them. When I said about the arguments against the motion of the earth, he's referring to Aristarchus and Heraclitus, who lived after Aristotle, or Heraclitus might have been a contemporary. So lots of different points are being mixed in here, not only the mathematical and not only purely physics, but other ideas about what makes the universe what it is.
Thanks. I think we have time for maybe 2, possibly 3. So one here.
Thank you very much for an incredible talk and overview. When I see those spheric concentric diagrams, I'm wondering, have you found any references in the literature to what people back then, in Aristotle's time, thought about the edge of space? Did they have ideas about what was beyond
Absolutely.
that?
Yeah.
Or was that the boundary of space?
No, I mean, it's a very good question. It's a very interesting question, and it's something that quite a few people do talk about. I mean, can you reach beyond or not? And there's not agreement about it. Some people, like Aristotle, think it's bounded, and this is what we've got. Others think no. So once again, a topic for another day, but a very good question, and one that reappears later on, particularly in the early modern period.
Thank you.
Do you think if we compare medieval and early modern scientists with current ones, there's a difference in psychology in that the early scientists wanted to emphasize continuity with the authority of the ancients, whereas a modern scientist with a new idea would be emphasizing the difference from the previous theory?
Also a great question, and one I'm very grateful for. It's something that I've thought about, and particularly in terms of Pythagoras. So I didn't bring it with me because I didn't anticipate the question, but Whitehead refers to the influence of Pythagoras in the 20th century. Einstein does as well. And I know Lord Rees, I once asked him very deliberately, what do you think of this? And he said, oh yes, we do have our roots there. So I didn't want to have too many images. It's one thing that's very interesting was how much Pythagoras was also celebrated and venerated. During a very long period, over 1,000 years in antiquity, there were coins that were minted showing him seated as really a great figure. And so I don't know. And I mean, I'm turning to Rob there, who's the later period is his period, not mine. It's interesting, and it kind of comes to the question about, is it a paradigm or a tradition? And how people, even in their own times, wish their own work to be understood, how they wish to be understood, whether or not they're doing something entirely new, or whether or not they're standing on the shoulders of others and just kind of tweaking something. These are interesting questions.
This, unfortunately, will have to be the last question.
It may be very brief answer, which may help us with the time. But the question is, clearly there was the insight already that the Earth was tiny compared to the heavens, the reference to the point. Was there any insight or even thought about the scale of the other planets and the Sun? Because
yes.
Of course, the reason that everything tilts to the Sun being center of the solar system, very close to the center of gravity, is the abundance of matter in the Sun itself. Was there any thought that the Sun had to be certain size, and therefore it might be a good candidate?
Yes, and I point again to Aristarchus then, as very deliberately talking about the size, writing a work, the size and distances in the sun and moon. And in fact, the historian of Greek mathematics, one of his books has a title, something like Aristarchus the Ancient Copernicus, or something like that. But Ptolemy and others were very interested in trying to have some estimate of what the size of the universe was, and not only the order of the planets, but what the distances were between them. And this was one of the big problems for Copernicus, in terms of what is the size of the universe? And he knew that he had to posit it to be much larger than we would have thought
The
otherwise.
size of the sun
Oh, the size of the sun.
versus the size of the earth.
Oh yes, and this is also talked about very much in antiquity from early on for all sorts of reasons, and gets some people into trouble whether or not they think it's something very small, for instance, or very large. I mean, this is arguments both ways.
Okay, thank you very much. A round of applause again, please.